Hi everyone, welcome back to the GCSEMathsPro YouTube channel. In today's live we'll be going through a foundation paper actually. So this is the first foundation paper we've been through, but we will be going through them this week and obviously leading up to the next two exams as well. So the one we've got today you can see here is the June 2023, obviously paper 2 foundation from Edexcel. We will be doing paper 3 on Wednesday as well. We're going to go through both paper 2 and paper 3 for the next couple of weeks because they kind of just mix the topics, so it's best to just know and have seen at least both of them so that you can see all of the different topics. So when will we do higher paper? The higher paper is at 7 o'clock, so in 2 hours you can come back and we'll do the higher paper. Today's higher paper is actually the November 2021 paper 3 though. You can see it listed on my channel. All the higher papers I normally do at about 7 o'clock. And the foundations I'm going to do at 5 o'clock. Okay? Perfect. Alright. Okay, I'm just going to start talking through it, and if you join later on you can obviously rewind and go through it later on as well, that's fine. So we have obviously a selection of questions here for 1 mark. We've got right 6,184, correct to the nearest 100. So the hundreds, obviously as I kind of read it out, is the 1, isn't it, here? Let me make that a bit more clear. It's kind of vague. This 1 here, that third digit is the hundreds, isn't it? So rounding to the nearest 100, I'm going to look at the digit next to it, which is an 8, and that will tell me whether I need to round up or round down. Because it's 5 or above, 8 is obviously above 5, isn't it, bigger than 5, it means I need to round up. So that would round up to 6,200. It's closer to 6,200, isn't it? If you think about it like that, they're saying the nearest 100. It's closer to 6,200 than it is 6,100. Then we've got question 2, write 0.7 as a fraction. Now this is a calculator exam, so what you can do is grab your calculator if you don't already know the answer, type in the decimal, and it should come up as a fraction. Or if it doesn't, you should have like some kind of conversion button, like an SD button. You can always press that if it does give you the decimal and then make it convert it for you. So that is just 7/10 or 7/10. Then at question 3, we've got change 9 meters into centimeters. So you do need to know this conversion, how many centimeters are in a meter. So 1 meter is 100 centimeters. We just have to have memorized that basically. So if we've got 9 meters, that's just 9 times the 100, isn't it? 9 times the amount. So that should be 900 centimeters. Okay, so that one you do have to have memorized. Scroll down a bit. Question 4, we've got some algebra, so simplify 3 times 4t. So we're just multiplying the numbers, aren't we? 3 times 4 is obviously 12, and the t is still there. So you just stick that on the end. So 12t. Question 5, here is a list of numbers, 20, 40, 60, 80, 100. One of these numbers is a multiple of 25. So if you think about the 25 times tables, one of them would appear in that list. So they're saying if it's a multiple of 25, it can be divisible by 25. We can divide by 25 equally. So obviously 20 is already too small, isn't it? It has to be bigger than 25. Does 25 go into 40? If you're not sure, as in, obviously, if you already know the answer, just write the answer. But if you're not sure, you can just go through and divide them all. So like 40 divided by 25. If you don't get a whole number, do you see how that's not a whole number? It's not that. So it's not 40. 60 divided by, oh, not 0, 60 divided by 25. Again, see how that's not a whole number. So it's not 60. 80 divided by 25. Again, we're getting fractions here. They're not whole numbers, are they? So last one. Do you see how now 100 divided by 25, we've got a whole number? So that means it is a multiple of 25. You just do 25 times 4 to get 100. So the answer would be 100 for this one. Okay, question 6, we've got Sherry has a fair ordinary dice. She rolls the dice once. A fair means that there's a equal chance if you roll the dice of landing on any of the numbers. It's not like it's not like it would always land on a 6, for example. It's going to land on each of the numbers in an equal kind of chance. And an ordinary dice, they mean like it's got 6 numbers. So she rolls the dice once. On the probability scale, mark with a cross the probability that Sherry gets the number 7. Now, I've just said that obviously a dice, 0 exactly, a dice goes from 1 to 6. There isn't a 7. So there's literally 0 chance of getting a 7. It's impossible. Part B, on the probability scale, mark with a cross the probability that Sherry gets an even number. So think about a dice. We've just said it goes from 1 to 6. 1, 2, 3, 4, 5, 6. How many of those are even numbers? 2, 4, 6. Do you see how that's 3 out of 6? Or in other words, literally exactly half, isn't it? It's exactly half. So half of them are odd, half of them are even. So the chance of getting even is a half. So that's for 2 marks, that one. Question 7, here is a triangle. The triangle is accurately drawn. We need to measure the length of AC. So obviously you would get your ruler, right? Now, I think I can measure it, but it might not be accurate to the actual page size, right? Because obviously mine's digital. But you would just get your ruler. I think I have to do mine with a straight line. So this is how I'm going to figure it out. Let's just say you'd obviously mark your ruler along this line. You can see mine gives me some kind of centimeters. Mine says 8.3. In reality, I'll look at the mark scheme, obviously, because I said mine is not accurate. On the mark scheme, they have said that you should get 9.3. So mine is obviously not quite to scale. But basically, just get your ruler. This one, ruler. Now, they have said you can get an answer between 9.1 and 9.5. Their official answer is 9.3. But if you get anything between these 2 values, then they'll also give you the mark. We've then been asked to measure the size of angle B. So this angle here. So obviously you would get your protractor. So you would, I'm assuming, have a kind of 180-degree protractor, just like a half protractor. I'll try and show you because I don't have a protractor digitally, unfortunately. But I would line it up. You could either line it up on AB, or I'm just trying to imagine my protractor. You could line it up on AB and go backwards, or you could line it up on BC. It doesn't really matter which one you line it up on, I don't think, as long as you read it off correctly. Let's say I've lined it up on BC. So obviously your protractor has a straight line, doesn't it? So you want to line up the straight line here, and you want to get the middle of the protractor on B, and then if you imagine it like this, I'm just trying to draw it for you. That's kind of your protractor, isn't it? So then obviously whatever your line is starting from 0, you'd read up to here. So what they've said is ideally you'd get about 106. So this would be 106 from 0 to 106. Okay. Now again, there is a range though. So as long as you've got something between 104 and 108, that's fine. Okay, so that's with your protractor. Then we've got part C, so we've actually got a different triangle now. This is completely different. So we've been told, here is a different triangle. They've said that QP is equal to QR, so the side QP is the same as the side QR, so those two are equal. Write down the mathematical name of this triangle. So when 2 sides are the same in a triangle, it's an isosceles, isn't it? Isosceles triangle. It's quite hard actually, that one, because it's kind of hard to spell, but they said they will allow incorrect spelling as long as it's kind of clear that you're trying to say isosceles generally. So don't worry about necessarily spelling it, as long as it kind of looks similar, you know, as long as they can kind of recognize it, because I realize that one is obviously really hard to spell. So as long as you've kind of said isosceles somehow, then they will accept that. So yeah, if you've got 2 of the same sides, it is an isosceles triangle. Question 8, the diagram shows 3 motorway service stations P, Q and R on a map. The map has a scale of 1 centimetre is equal to 4 kilometres. So you can see we've got 8 centimetres and 16 centimetres, but then they're going to now ask us to work out the real distance from P to R. So the whole thing So the first thing I would say we need to do is work out in centimetres the whole thing. Now I'm not going to get my ruler this time because it's not literally drawn accurately like that. They've told me the centimetres of the two parts. So P to R in centimetres is obviously just the 8 plus the 16. So 24 centimetres. So that's the first thing. After that, that would even just get you 1 mark. After that, we obviously are going to convert it into kilometres. So for every 1 centimetre, we need 4 kilometres. So if I've got, I'll line up, same as I did with the metres and centimetres earlier. Here's my conversion, and then I've got 24 centimetres. I just need to times it by 4, don't I? 24 times 4. So you can grab your calculator, obviously. 4 times 24 is 96 kilometres. So your answer is 96. But even if you just added the 8 and the 16, you still get 1 mark for that. So even if you weren't sure about the kilometre bit, you can just add the 8 and the 16. That's already 1 mark anyway. Question 9. Here are the first 5 terms of a sequence. 3, 8, 13, 18, 23. Write down the next term in this sequence. So you can kind of see, if we have a look at the sequence, that there is an equal distance every time, like a difference, isn't it? We've been adding 5 every time, 5, 5, 5, and so on. So what I need to do is just take 23, the last term that they've given me, and add another 5. So it should be 28. And then part B, write down the ratio of the second term to the fourth term. So the second term is 8 and the fourth term is 18. So you can see it's 2 marks. My first thing is I'm just going to write it as a ratio in that order, so that order that they've written it. So I'll put 8, a ratio is the one with the kind of colon, isn't it? And then 18, that's the first thing. So that would probably give you the first mark. But they've then said in its simplest forms, I need to simplify that. You can obviously simplify it as is, or if you want to, depends if this makes sense to you or not. Sometimes I just simplify it by using a fraction. So, because ratios do simplify in the exact same way as fractions. The only difference is that a ratio, you've got them like stood next to each other, and a fraction, they're just one above the other, isn't it? They're just in a different format. But you see, if I write that, simplified, see how it gives me 4 and 9? So where the 8 used to be, it's now 4, and where the 18 used to be, it's now 9. So do you see how that I could just translate to 4 to 9? If you want to do it that way, you can obviously simplify it yourself. They've only just divided it by 2, haven't they? But you can also use the calculator, seeing as it's now paper 2, paper 3. Yeah, this is my first time doing foundation because quite a few people have asked for it. But yeah, I'll see you in the higher one in a couple of hours. So question 10, this graph can be used to find the cost of parking a car in a car park for up to 12 hours. You can see x-axis is the number of hours up to 12, and then the cost is the y-axis. Use the graph to find the cost of parking a car for 4 hours. So I'm going to get my line. You don't have to obviously draw it necessarily, I guess, but I'm just going to show you with my line. Let's get a colour. So they said 4 hours. So coming to obviously the x-axis, because that's the number of hours, isn't it? Where is 4? 4 is here. Go up to my line. You see where it meets the line. That's where I'm going to then go across, because I want to read off the y-axis, the vertical one, because that's the cost, isn't it? So that is £6. Okay, it's just literally reading it off like that. Now there is also a part B. Justin drives into the car park at 8 AM in the morning. When he drives out of the car park, he has to pay £9. At what time does Justin drive out of the car park? So £9 is now. Do you see how now, compared to part A, they've now actually given me something from the y-axis. So we can get maybe a different colour. From the y-axis, it said £9. So just be careful of the scale. That's 8 and then 10. So 9 is obviously the halfway point, isn't it? From 9 all the way across, again, you see it hits the actual graph line and then down this time. So first of all, that's telling me it's 6 hours. Justin has stayed in the car park for 6 hours, but that's not the actual final answer in this case, is it? You see how we've got 3 marks? that wouldn't be enough for 3 marks. So at 6 hours, however, they've actually put a time to it, haven't they? They said he actually came at 8 a.m. He stayed there for 6 hours. What time does Justin drive out? So not how many hours, it's what literal time. So I'm going to just obviously take 8 a.m. and figure out what time it would be 6 hours on. So you go 9, 10, 11, 12, that's 4 hours, and then 1, 2 p.m. So you can write 2 p.m. as in the format that they've done it, which would be like this, wouldn't it? 14, that's 2 p.m. Or you can write 2 p.m. like this. It doesn't really matter as long as it's, obvious. Don't just write the number 2 because that doesn't really mean anything. So yeah, either of these, you can work it out however it makes sense to you, basically. Question 11, the table shows information about the weights of the people in a hotel lift. So we've got the weight in one column and then the number of people for each of these weights in the other column. Show that the total weight of the people in the lift is less than 1,200 kilograms. So we just need to multiply across. We've got one person that weighs 40 kilos, so that's just 40 kilos, isn't it? But here we've then got 2 people that weigh 50 kilos, so in total that would be 100 kilos, wouldn't it? And then here we've actually got 4 people who weigh 60 kilos, so I need to, that's meant to be a multiplier. 4 people weigh 60 kilos, so that would be 240. You can obviously put it in the calculator if you want to, that's fine. Then we've got 5 people who weigh 70 kilos. So again, multiply that. 3 people that weigh 80, 240 again. And then 1 person weighs 90, so that's just the 90, isn't it? And then I would want to add all of these up, so I might actually get my calculator for that. So I've got 40 plus 100 plus 240 plus 350 plus 240 again plus 90. We've got 1,060 kilos as a total. Now they said show that it's less than 1,200. Well, it is, isn't it? It is less. So that would be fine. That would be enough. I mean, you can obviously write it down here, but I'm just showing you next to the table. Now, just to show you how many marks this one was, 3 marks. Okay, question 12, shape A is reflected in a mirror line to give shape B. On the grid, draw the mirror line. So we need to figure out where the mirror line is. So in my head, because let's look at just the base. The base of the triangle was horizontal. Do you see how the base of B is now vertical? That's like a kind of 90-degree shift, isn't it? So I'm thinking my reflection is obviously not just a straight, as in horizontal line. It's not a vertical line. It's going to be a diagonal line, because otherwise how would you go from here to here? It's kind of, it looks like it's rotated a bit. I know they're saying it's reflected, but it kind of looks like a rotation as well, doesn't it? So sometimes I just try and imagine it. I guess you can always put your hand, upright. Imagine that your hand is the mirror and just put it and just try and imagine how things would reflect. But what I was thinking is it's going to be kind of diagonally in the middle, obviously an equal distance between. So it would go through this point here, wouldn't it? And then an equal distance between these two. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 would be here. And then I'd probably just join that up, as in obviously extend it through the rest of, it's meant to do it in black, but you get the point. That's where I would put my mirror line, just diagonally, because it's kind of, it's not just reflected down or across, as it's kind of rotated almost. So it's going to be a diagonal mirror line, obviously literally in the middle between the 2 shapes. So that's 1 mark. Now I think there's also another one. Yeah, part B is on the 2nd page. So Alex is asked to reflect shape P in the x-axis. Here is the diagram Alex draws. So he's been asked to reflect it in the x-axis. Explain the mistake Alex has made. So you can always try and figure out how you might do it and then see how your answer is maybe different to Alex's answer. For example, if you're not really sure initially, you can always try and work it out yourself and then see what is different. They've said the x-axis. The x-axis is this, isn't it? And you can see it's literally labelled x, that one's labelled y. So that if that was your mirror line, if you, again, imagine putting your hand there as a mirror across that line, this shape P would reflect down, wouldn't it? Technically, you don't have to draw this, but just to show you, it would be obviously an equal distance from the x-axis, and the shape would be the same size, but obviously now it's kind of like flipped upside down. That would be the shape. Do you see what he's done? He's actually reflected it correctly, but in the y-axis. He's not reflected it correctly in the x-axis. So you could say something like that. There's loads of acceptable answers, right? I'll read out a few. The first thing is he didn't actually reflect it in the x-axis. That's probably what I would write. He didn't reflect it in the x-axis, did he? He reflected it in the y. Or the other one is he reflected it in the y, you know? He reflected it in the y-axis instead. So one of these, that's fine. Now, other options they've said Alex didn't reflect in the or on the x-axis. Alex drew it on the y-axis, or he didn't draw it on the x-axis. It should be in, you could say it should be in the bottom right box. You could say which quadrant it should be in. It should be in this bottom one here on the right, shouldn't it? You could say that. It needs to be reflected down, not across. They would accept that. Vertical reflection instead of horizontal reflection. That sounds kind of complicated. I don't think I'd write that, but they've accepted it. Drawn in the correct position on grid and statement should be there. Oh, okay. Oh, okay. You could draw it here like I've done, and then you would have to say it should be here. You could also do that. You can correct it. It should be here. You could do that. That could be an answer. So you've got kind of 3 different options there. Some form of that. Okay. Question 13, we've got, there are 50 teachers in a school. There is, this is 1/16 of the total number of people in the school. Work out the total number of people in school. So 50 teachers is equal to 1/16 of the total, isn't it? Now we want to know the total. So what I'm going to do is go, well, if that's only 1/16, technically the total is 16 out of 16, isn't it? So do you see what I'd have to, how would you go from 1 to 16? You just multiply by 16, don't you? So my calculation is I need to times by 16. You could also technically divide by 1/16. It depends who that makes sense to. It might not make any sense to you, but same thing, right? Timesing by 16 or dividing by the fraction. It's up to you which of those methods makes more sense to you. I probably just times it by 16, to be honest. Obviously, your answer has to be bigger, doesn't it? Because they said there are 50 teachers in school. That's only 1/16. That's only a small proportion, isn't it? Obviously, there's going to be more people than just the teachers in the school. So you should get a bigger answer, but you can see you got 800. So as long as you get 800, then that's fine. Question 14, packets of sweets are put into boxes. So you can see here the packet, we've got 80, and just pay attention to this, it's millimeters by 60 millimeters by 20 millimeters. But then the box is in centimeters. You see that? We've got millimeters and centimeters, so just be aware of that. And each box is a cuboid, as you can see, 72 centimeters by 48 centimeters by 24 centimeters. Work out the greatest number of packets that can be put in each box. So try and imagine this. I'm going to look at the 3 measurements. I've got the front measurements. I'm going to highlight it just to show you. Like, this is the same as then this one. As in, obviously not in terms of literal distance, but or size, but you know what I mean. I'm going to compare those 2 sides. That's that one. Where's my orange? And then the height. So what I did was I said, right, I think what I did actually first of all is, as I just said, we've got millimeters and centimeters. I'm going to convert, you can convert them either way, both into millimeters or both into centimeters. I prefer centimeters, that's just my choice. You could do whatever makes sense to you. Again, another one of these things that we need to know, 1 centimeter you need to know this conversion, is 10 millimeters. If you just, I mean, you've got a ruler in your exam, you can kind of look at the ruler, can't you, and see that there are 10 kind of markings between each centimeter. So how many, what are my measurements in just centimeters? Well, this one, you just divide by 10, don't you? That would be 8 centimeters, 6 centimeters, and 2 centimeters. Might get rid of that in white because that's looking a bit messy, isn't it? There you go. Now you can see it a bit better. So we've got 8 by 6 by 2 instead. Okay. So then what I did was I said, right, let me just look at, let's say, the green side. How many boxes, or how many packets would fit in the box just across in the green side? Now, by doing that, I did 72 divided by 8, which is in the times table, so you might know that. If not, obviously, you can always use your calculator to double check. It does give us 9, so that tells me that I could fit 9 packets across. 9 packets across. Then I've got to look, well, how many would fit back? So just do the exact same thing, but as you can see, I've matched up the sides. So 48 divided by 6, again, you might know what that is. If not, just divide it. Is 8. So I can fit 9 packets across, 8 packets back. How many can I stack on top of each other up, you know, vertically? And again, well, that one you can probably figure out. 24 divided by 2 is obviously 12. So I can fit 9 across, 8 back, and 12 up. Then all I need to do to make that kind of like a 3D scenario is multiply those together. I can actually fit loads of packets. It's actually a really big number. So 9 times 8 times 12. 864 should be your answer. 864 packets. It seems, I don't know, when I got this answer, I felt like it was really big, but yeah, that is right. You can fit 864 of these packets in here. I guess obviously it's not drawn to scale, as it's quite hard to imagine, but yeah, you can fit 864 of them into that box. Question 15, here is a fair ordinary dice. So again, as we mentioned before about the fair ordinary dice, it's obviously got 6 sides with 6 numbers on them, and it's fair in terms of if you rolled it, it could land on any of the numbers equally, couldn't it? It's not leaning towards one of the numbers more than any of the others. And a fair 8-sided spinner, so it's got 8 sides, but again, it's fair, so the chance of landing on any of these 8 numbers is equal. Charlie throws the dice once and spins the spinner once. Is Charlie more likely to get a number less than 3 on the dice or a number greater than 5 on the spinner? So let's think about it. The dice we've said earlier was 1, 2, 3, 4, 5, 6. So a number less than 3, that would only include 1 and 2 because it wouldn't include 3, would it? It's less than 3. It doesn't include 3. So what's the probability of this? Well, there's 2 chances, 2 options out of 6 numbers, isn't there? Out of 6 possibilities. So you see how that would give me 2 out of 6. Then the other one, let's look at the other one. A number greater than 5, that would be 6, 7, or 8. Again, it doesn't include 5, does it? It's just greater than. Anything bigger than 5. 6, 7, and 8. So what's that probability? Well, there are 3 chances to get it greater than 5 out of the whole thing, which is 8 different options. So these are my 2 probabilities. Maybe if I label them. This one is the spinner, and then the dice was 2, 6, wasn't it? Now, what I would do to see which is bigger, which is more likely, it just means a bigger probability, doesn't it? Is I'd get my calculator. I'd probably look at them as decimals personally. So you can just type in 2 sixths. I mean, obviously, if you already know what that is, that's great. It does simplify to 1/3. However, if I then look at the decimal, if you want to convert from fractions to decimals, as we said before, you can just press the SD button, it will convert them. 0.333 recurring. So I'd write that 0.3333 forever, right? Recurring. And then the spinner is 3/8. So we can change that to 3/8. As I said, convert it to a decimal, 0.375. Then all you have to figure out is which number is bigger, which decimal is bigger. Well, we should say, obviously, you've got 333. This is 37. That's already bigger, isn't it? You could convert it to percentages if you want, if that makes sense to you. A lot of these, there are different ways to do it. It's kind of whatever makes sense to you, basically. So I would say, is Charlie more likely, which one is Charlie more likely to get? Well, whichever one has a higher probability. So I'd say, therefore, Charlie is more likely, just make your answer obvious, to get a number greater than 5 on the spinner, isn't it? You don't have to write, you could copy this down if you want, or just write spin, as long as you made it clear that it's the spinner. You do have to write that as your final kind of answer, yeah. But you can compare it. I compared them with decimals. You could make both of the fractions the same and then look at the numerators. You could, as I said, convert them both to percentages. They have given the option to convert them to ratios. I don't know why you would do that, to be fair, but you could if you wanted. So there's loads of ways to do it, as long as you've made a direct comparison. Do you see how I've compared the decimals? This one is obviously bigger than 0.3 recurring, isn't it? So therefore the spinner is more likely to happen, that scenario. So that was 3 marks, as you can see. Question 16. Paolo drives at an average speed of 56 kilometers per hour for 1 hour 45 minutes. Work out the distance Paolo drives. So this is obviously speed, distance, time. I like to use my formula triangle. Just have to remember that distance goes at the top. So we're looking for distance, so I cross that one out. And then the ones at the bottom we always multiply. So that means distance is equal to speed multiplied by time. Now, the only thing I need to do though is, do you see how the speed is in kilometers per hour, but then the time, this is speed, isn't it? This is the time. But then the time is in hours and minutes. You have to make sure that those are the same units. Obviously leave the speed as it is, the speed is fine. We're going to change, before I multiply it, we're going to change the time into just hours. So the way that we can change it into just hours is, obviously it's 1 hour, so it's going to be 1 point something, isn't it? And a decimal. The way that you can change any minutes into hours is just obviously divide by 60, because there are 60 minutes in an hour. You might also know what that is anyway, maybe as a fraction. But I mean, we know 45 minutes is 3/4 of an hour, isn't it? Which as a decimal is 0.75. But there was also 1 hour as well, wasn't there? So do you see how that would give me 1.75? That's what I'm going to use. 1.75 hours. So times it by 1.75. So with speed, distance, time, you have to make sure that whatever your speed is in, it does match the time and the distance and so on. So 56 times 1.75 is 98, and that would just therefore be kilometers. 98 kilometers. Okay, so it's not just using the formula triangle, it's also converting the time correctly. Oh, for this one they have actually given you a range, by the way. I didn't know how you'd, I guess, get a range, but anyway. They've given you 97.65 to 98.3. So, I mean, you can see 98 is like the official answer, but if you get anything between those two values, then they'll also accept it. Okay, question 17. There are 3 cinemas, A, B, and C. The mean number of seats per cinema is 380. There are 350 seats in cinema A and 250 seats in cinema B. Work out the number of seats in cinema C. So this topic I would call reversing the mean. We need to kind of undo it, go backwards. Because what they would have done, let's think about it, how have they worked out the mean? They would have taken A, number of seats obviously, plus B, plus the C. When you work out mean, you add them all up and divide by how many there are, don't you? So you divide by 3, because there's 3 cinemas. That would give you 380, wouldn't it? That's the mean. Now, do you see how I do know the values for A and B? So if I come back, get rid of A, that's actually 350, isn't it? Come back, get rid of B, see if I can fit that in there. That's 250. Do you see how now, I mean, this depends how much you like algebra. I kind of lean on algebra quite a lot to figure things out. But I've basically got an equation here with just C. And that's the thing I want, isn't it? They've asked me to find out C. So I guess you could just add these together, couldn't you, to start with? Might as well do that. So 350 plus 250 gives you 600. So we've got 600 plus C over 3 is 380. So now I'm going to reverse the mean. Do you see how I could reverse it by, when you do the mean, you divide by 3, in this particular case, obviously, because there are 3 cinemas. But to reverse it, I'm then going to times by 3. You know, with algebra, if you want to, I want to move the 3 across to the other side of the equation, you always do the opposite, don't you? And a fraction means divide. So I'm going to multiply both sides by 3. Obviously, on the left, the 3 just cancels out. That's the whole point. But I also do need to do 380 on the right-hand side by 3, which is 1,140. So then I'm left with just 600 plus c is equal to 1,140. And I'm just trying to get basically c on its own, aren't I? I'm just trying to get c on its own. So do you see how now the final thing that's in my way is the 600? I want to move the 600, and the 600 is currently a positive, so that means I need to subtract it, do the opposite. So subtract it across, c is equal, so that would just obviously cancel out the 600s. And then 1,140 minus 600 gives you 540. So I have reversed the mean. I've done the opposite, literally the opposite process, haven't I? As you would normally do to find the mean. So that means that there are 540 seats in Cinema C. So that's how I would kind of think to do it. You obviously can do it in different ways. When you look at the mark scheme, there's like 3 or 4 different ways to do it. So it's not that you have to do it my way. You can do it whatever way makes sense to you. If you've got the answer 540, then yeah, you're right. So don't think that you have to do it this way if it doesn't make sense. If you've figured out your own way and you still get the same answer, then that would be fine. Okay, question 18. Asha buys 180 cans of cola. The cans are sold in packs. There are 12 cans in each pack, and each pack costs £3. So work out the total cost of the cola Asha buys. So how much does she pay in total? So there's 12 cans in each pack, and then we've got the price per pack. So what I would do is go, well, I want to know how many packs of cola did she buy? So that would mean doing the total number of cans divided by how many cans are in each pack. That would tell me how many packs there are. So 180 divided by 12. Okay, so that tells me that Asha bought 15 packs of cola. Now, if each pack costs £3, then I just need to times that by 15, don't I? Because it's 15 lots of £3. So 15 times 3, doesn't matter which order you times it in, you'll get the same answer. 45. So Asha paid £45 for that many cans of cola. Okay. Part B, we've got something completely different here now. So Ethan buys a box of 24 cans of lemonade for £7. There are 330 millilitres of lemonade in each can. Work out the cost of 100 millilitres of lemonade. So, I mean, the same kind of general logic, but it's not the same like scenario, is it? We've got a different scenario here. So this one's, I guess, a little bit harder. And again, there are different ways to do it. You might do it in a different order than the way I've done it. What would I think to do? Maybe I would work out how many millilitres of lemonade I have in total. So one can is 330, but I have got 24 cans. So maybe I would do that. Maybe I would times 24 by 330. 24 times 330. No, not by 33, 330. Okay, so in total I have 7,920 millilitres of lemonade. That's how many I have in total, and that cost £7, didn't it? Is there a higher one? Yes, the higher one is at 7 o'clock. Okay, so you can come back and join us in the higher tier paper at 7. So that's my total number of millilitres of lemonade I've got, and we know that the total cost of that was £7, wasn't it? Now I want to know per 100 millilitres. So I need to know how many 100 millilitres I have. So I think I'd probably divide my total millilitres by 100 millilitres. You could probably figure that out yourself, but we can also put it in the calculator. That would tell me how many lots of 100 mils I have, wouldn't it? divided by 100, which gives me 79.2. That's like 79.2 lots of 100 mils. Sorry, at 7 o'clock it is. You can see them listed on my channel. There should be one today at 7 o'clock. Okay, so then to find the price or the cost of the 100 mils, I would then do £7, or you could change it into, well, they've actually given it, they've said give your answer correct to the nearest penny, haven't they? So maybe if we change the £7 first into pennies, and again, that's a conversion that you would need to know. So £7, there's 100 pennies in a pound, isn't there? So that'd be 700p. Let me write that better. Yeah. So I think then I would go, right, 700 divided by 79.2. Now it does give you kind of an annoying answer. Let me show you actually on the calculator. Hang on. So 700p divided by 79.2 lots of 100 mils is, you can see it's a recurring decimal, 8.8383. That's why they said give your answer correct to the nearest penny. So the nearest, that's 8.8p, isn't it? So I'd round that to 9p. So 8.83, you could write that ... and then round it up. Oh. And then round it up to 9p. The answer is 9. Officially, yeah, they've not given a range for that. That's just the answer. Now, as I said, you might have done it differently. Then that's fine. As long as you've got 9p at the end, that's fine. So question 19, 240 people work at a factory. Of these people, we've been told that 150 have a car, 110 have a bicycle, and then 65 of the people who have a bicycle do not have a car. So do consider the fact that obviously just because they have a car, they might also have a bicycle or vice versa. They could have both, they could have one of each or neither. So use this information to complete the frequency tree. They've obviously put the 240 as your total. They then split into have a car, do not have a car. So you can see there's 150 have a car, so that's fine, 150. Now what goes here would have to add back up to the total of 240, wouldn't it? So 240 minus 150 is 90, so 90 don't have a car. And then this is the bit where I guess it gets a little bit more confusing, isn't it? So we've dealt with that. 110 have a bicycle. However, that means we can't just write that in immediately. That is this bubble and this bubble add up to 110. Okay, so we need to figure out how it splits between the two. So let's look at this next line. The 65 of the people who have a bicycle do not have a car. So that 65, we need to figure out where to put that. 65 of the people who have a bicycle do not have a car. So it's do not have a car, but they do have a bicycle. See how 65 would go here? And then, so I can tick that off. Then, as I said, those two bubbles, the orange ones, add up to 110. So then you can figure out what goes here, can't you? So 110 minus the 65 is 45. So that one's 45. And then the last thing, then once you've got this far, then it's fine because as we said, it always has to add up to the previous one. So the 150 splits into 45 in this other circle. So 150 minus, just one minus 45. So 105 should be in this one. And then the other one is the 90, isn't it? 90 minus 65 is 25. There. So I think it's just that 65. Once you get that in the right place, then it's fine. Now, I guess we're going to use our frequency tree. So, see if you can still see that. Yeah, you can still see that. What percentage of the 150 people who have a car also have a bicycle? So that's talking about, you just have to figure out which bubble that's talking about. That's obviously, they have a car, they also have a bicycle. So how many also have a bicycle? 45. And they've said of the 150 people. So we're not looking at the 240 anymore. We're just looking at effectively this bit here, isn't it? That's what we're looking at. So we need to make that into a percentage. So that's obviously the 45 people out of the 150 people. Then, because you've got a fraction, when you make it into a percentage, you times by 100. So if you ever want to make any percentage, you always times by 100, isn't it? Because the 45 over 150 is going to give us a decimal. We want to have a percentage. And that gives me 30%. So you just need to do 45 over 150, basically. Okay? So nice 5 marks in total there. Right, question 20. Now, this is the bit where, I don't know if you guys, I guess you know this, I don't know if you know this. Obviously, the end of your foundation paper is the start of the higher tier paper. They have the exact same questions. Obviously, it's just at some point it starts to overlap. From this question is when it overlaps. So technically, this was question 1 in the higher tier paper. So any questions from here onwards, they also asked in the higher tier paper. So actually, I thought it was only going to be like 5 or something, but I think it's like 7 or 8 questions. So technically, this is now higher tier. So you're talking kind of grade 4, grade 5 at this point, isn't it? So work out the value of 25 minus the square root of 43.87 over 6 plus 2.1 squared. Write down all the figures on your calculator display. So literally all they mean is type it into the calculator. They're just checking if you know how to do all of these different operations on your calculator. So make sure that you obviously do, because it's otherwise quite an easy question. 2.1 and then square the 2.1. See how I've just literally copied it? Then it says write down all the figures on your calculator display. So you need to write down all of that. Don't round it. Just literally write everything that you can see. So we've got 1.7. Let me move this over here so I can see it. 1.76527923. Literally, I'm just writing all of that down, basically. Okay. Then part B, completely separate this actually. Right, work out the value of the reciprocal of 0.625. So reciprocal is when you flip the fraction upside down. When you flip the fraction upside down. Now, as you can see, it's not currently a fraction, so it's not very helpful, is it? So as we saw in, I think it was like question 1 or question 2, to convert a decimal to a fraction when you have got a calculator, so I just type it into the calculator to see how now it gives me a fraction. And as I said, if it does give you the decimal again, just press the SD and it should convert it to a fraction. So I'd probably write that down and go, right, okay. So 0.625 is the same as 5/8. That's not the answer, because that is just the same thing. If I then want the reciprocal, as I said, flip the fraction upside down. You know when you do dividing fractions, keep, flip, change, it's the same logic. So the reciprocal would be 8/5. And just leave it as a fraction, that's fine. Now, you could also put that as a decimal if you wanted. So if I just type in, because I now know it's 8/5. 8/5, press the SD, it gives me 1.6. So they will allow 1.6 as well, 1.6 or 8/5, or if you wanted to put it as a mixed number, 1 3/5. Any of these is fine. They've just said or equivalent. So any of these, but I just went with 8/5 to be honest. Question 21, write 60 as a product of its prime factors. Now, there is actually a way to do this on the calculator, again, given that you've already done paper 1. What you can do is just type in the number, not 0, preferably, type in 60. Now, check on your calculator, because I'm sure yours is probably different to mine, but I don't know if you can see that as like a fact. It says fact here, mine says fact, and I press shift, and then it gives me the product of prime factors. Now, don't just write that as your answer though, because you do, can you see how it's 2 marks? They do want 1 mark for working out, which obviously using the calculator doesn't really include working out. So you can use that to kind of double check your working if you want, just to make sure you're right. Or what I have seen is what you could do is just list these numbers. So don't put multiply, just put like 2, 2, 3, and 5. That would be enough for working out. And then here, put the 2 squared times 3 times 5. You could do that. If you want to do it manually yourself, I normally do a tree. You can obviously break it down into any factors, but what I like to do is just use prime factors. So prime numbers are 2, 3, 5, 7, not 9, 10, 11, and so on. It goes on, doesn't it? Obviously up and up. I normally just start with 2, to be honest. If it's an even number, I can divide by 2, so that's 30. If it's still even, I divide by 2 again. When it's no longer even, I then look, is it 5 or a 3 maybe? In this case, yeah, both, 3 and 5. So do you see how I've got prime numbers there? So you can obviously do that if you want, but if you want to double check it on the calculator, then that's how. Question 22. There are 48 counters in a bag. There are only red counters and blue counters in the bag. The number of red counters to the number of blue counters is 1 to 2, so I like to kind of label it initials, red to blue. Helen has to work out how many red counters are in the bag. She says there are 24 red counters in the bag because 1 is half of 2 and 24 is therefore half of 48. Is Helen correct? Give a reason for your answer. So what you can do is actually kind of ignore Helen, work it out for yourself, and then see, does your answer match what Helen has? So we're just sharing out a ratio here, isn't it? The way we share out a ratio is we add up the numbers, so that'd be 3. So then you divide your total, which is 48, by 3, which isn't obviously a whole number, 16. So that means there's 16 counters per part. Now, what were they asking for? They were asking for red. Red is only one part, so yeah, that's how many red counters there are. So, do you see how I've actually worked out there's 16 red counters and not 24? So is Helen correct? No, she's not correct. You have to write yes or no. But you also obviously have to write a reason as well. So, some acceptable answers. You could say that 1/3 are red, not a half of them. You could say there are 16 red counters, which is what I've kind of written. There are 16 red counters. No, as she has used the ratio 1 to 1, not 1 to 2. You could say incorrect, as it is 16 red, 32. You could work out blue if you wanted, 32 blue. No, as she should divide by 3. That's what we did, isn't it? You could say actually she divided by 2, but you actually should divide by 3. And so on. You can kind of figure out different ways of saying no. Question 23, we've got some inequalities. So you can see here, they've said n is between -2 and 5. N is an integer, that means a whole number. So no decimals, whole number. Write down the greatest possible value of n. So in terms of this, n could be -2, -1, 0, 1, 2, 3, or 4. It includes -2 because it's got the equals symbol, but it doesn't include 5 because that one doesn't have the equals symbol. You don't have to list it like this, but I'm just kind of showing you. Do you see how the greatest value would therefore be 4? Not 5. Part B on the number line below, show the inequality -4 is less than or equal to m, which is less than 1. So you always put circles on the numbers. So -4, you put circle, and then 1, put circle. Now, because it's just m is between them, it's a range, isn't it? You're going to draw a line between to join them up. Now, the last detail is, again, we have this scenario where one of them, it's not 4.9 because n is an integer, which means n's a whole number. 4.9 is a decimal. It has to be a whole number. So the last detail is based on, this one has an equal symbol, doesn't it? Less than or equal to, so that includes -4, or less than 1, it doesn't include 1. So if it has the equal symbol as well, you colour it in. So just the -4 I'm going to colour in, not the 1. Okay. And then part C, we've just got linear inequality to solve. So just imagine this is like a normal equation. Obviously just copy the symbol. So we're solving this. Basically that means I want to get G on its own on one side and all of these other numbers on the other side. So I think the easiest thing to do is to move the 4. So the way that we move things, same as an equation, you just do the opposite. So it's currently wait for the helicopter to go by. It's currently -4, so to move it across I would need to add 4. And same as equations, you do the same to both sides. So add 4, so I've got still 2/5 G, copy the same symbol, And then 6 plus 4 is obviously 10. Now, the next thing, you can do it in either 1 step or 2 steps. It depends what you feel happy to do. We need to move, obviously, the 2/5. In 2 steps, you can obviously multiply by 5 and then divide by 2. Or, because this is a calculated question anyway, the 2/5 is technically multiplied by g, isn't it, as a whole? So what you could do is just divide straight by 2/5, because we have a calculator, so we can just chuck that in the calculator. So then you're left with just g, which is what we wanted. Grab my calculator again. And then on the other side, you need to do 10 divided by 2/5, which is 25. But as I said, you could do that in 2 steps if you wanted, because obviously imagine if you times by 5, you get 50, and then if you divide by 2, you get 25 again. So g is less than 25. As I said, just copy the same symbol, basically. Don't worry about the symbol, just copy it. But that's just like a normal equation. Question 24, here is a triangle and a rectangle. All measurements are in centimeters. The area of the triangle is 10 centimeters greater than the area of the rectangle. Work out the value of x. So when we work out the value of x, when it says work out the value of x, it is basically we need an equation again, don't we? We need an equation to then solve. So you're thinking, well, where do I get the equation from? Because you can't see one here. This sentence, I need to translate it, obviously from words, into algebra. So they said the area of the triangle. So how do you work out the area of a triangle? Area of a triangle, base times height over 2, or some version of that. So here, do you see how the base is 8 times the height, 6x, over 2. Okay, that's the area of the triangle. Whenever it says is, that's when you put equals. So equals. Then it says 10 centimeters squared greater than the area of the rectangle. Greater just means like additionally, isn't it? Plus. So you could put 10 plus the area of the rectangle. How do we work out the area of a rectangle? It's length times width, isn't it? Which in this case, so you can do 5 times, I'm using brackets just because it's algebra, but that means multiply, doesn't it? It means times 4x minus 1. So do you see how I've just translated this into algebra? Now forget about the whole context, don't worry about that. Let's just focus on our equation. Now all I need to do is just try and solve this. So that just means we've done it already technically in the previous question with g. I want to get all of the x's on one side and then all the numbers on the other. So it's going to be just kind of a slightly long process of rearranging. So this one, let's work it out. 8 times 6 is 48, isn't it? 48x over 2. Leave the 10. Let's expand this bracket here. 5 times 4x is 20x. 5 times minus 1, just double check, that is a negative, isn't it, is minus 5. Now this one I can then just divide by 2, can't I? What is half of 48? Again, you can put all this in your calculator if you want. Actually, this side, you know what, let's do that whilst we're here. When we say collect the like terms or simplify, do you see how the 10 and the 5 are just numbers? So those are like terms, aren't they? They're the same thing. So I can just add those together as in 10, well, technically 10 minus 5, isn't it? So do you see how that would be? 20x is still there. 10 minus 5 is just 5, isn't it, left over? So you see how I'm just slowly kind of simplifying it in each step. Now, I've got x's on both sides. Obviously, as I said, originally, I want to have x just on one side. So you need to move either the 24x or the 20x. Now, it doesn't really matter which. You can technically do either. I just like to try and make my life easier. Ultimately, I want to have a positive amount of x's. So I'm going to move the smaller number. See how 20 is the smaller? It's obviously smaller than 24, isn't it? Now, as we said, moving it is technically a positive 20, isn't it? It's not negative, it's technically positive. It's just stuck there, added. So the opposite would be to subtract it, wouldn't it? I'm doing this because I'm now moving things across to the other side of the equation. So think about this. Because these are both x's, they're also like terms. So I can actually subtract directly. 24x minus 20x, how many x do I have left? Only 4. And on this side, I cancelled out the 20x, it's just 5 left. So I'm almost there. My last step is then I don't want 4x, I just want 1x. So how do I get rid of the 4? This one is currently multiplied, isn't it? I know they don't write it, but technically that means multiplied, isn't it? 4x means 4 times x. So to move the 4, the opposite is to divide. Obviously on both sides. So dividing on this side, 4 divided by 4 is obviously 1, so just x. And on this side, you can leave it as a fraction if you want. You could also leave it as a decimal if you, again, put it in your calculator. We'll tell you the decimal, but I would probably just leave it as a fraction, to be honest. If I press SD, see how it tells me 1.25. So the answer is either 5 over 4 or 1.25 or 1 1/4. That's all the same thing, isn't it? Whatever format you prefer, because if I go back to the question, it just said work out the value of x. It didn't really specify how to leave your answer in a fraction, decimal, whatever. So it's up to you. 5 over 4. Or you could say 1.25. It doesn't really matter. But you see how that's the value of x, because I've just got x on its own on one side. That's solving, isn't it? 4 marks for that one. Obviously, that was quite a big question. Okay, we've got 4 more. So question 25. Last year, a family recycled 800 kilos of household waste. 57% of this waste was paper and glass. And then they've said the weight of the paper recycled to the weight of the glass recycled was 12:7. So again, I like to put P for paper and then G for glass. You don't have to do that. I just like to visualize it like that. Calculate the weight of the glass. So we've just got percentages and ratios here, haven't we? So first of all, normally it's kind of in order of how they've written it. We've got 800 in total. That obviously includes paper and glass, but it also includes other things. So I first need to work out 57%. So 800, the way that I work out 57%, especially because this is a calculator, is you have to multiply it. Now, there is actually a thing on the calculator. 800. If it's going to let me type 800, that'd be great. Times. Now what you can do is just put 57, but not just literally like that, right? Again, somewhere on your calculator, might be different to mine. Do you see how here above the bracket I've got this percentage button? You could do that if you wanted. And then it would, obviously it needs to be a smaller value than 800, doesn't it? It would work out for you. Obviously, if you're not sure how to do that, basically what we need to do is when we use percentages in a calculator, it always has to be a decimal. Now, percentages are always out of 100, aren't they? 100%. So technically you can just do 57 over 100 if you want to do it that way. That's also fine. However you want to do it, as long as you end up, what number was it, with 456. So what we're saying is 456 kilos was paper and glass, isn't it? So I've got rid of the 800, dealt with that, dealt with this. Now that I've just got the glass and the paper on its own, I can now deal with the ratio, share out the ratio, which we saw in the other question, didn't we? How do we share out a ratio? You have to add the ratio, so that's 19, and then you divide your total. The total is now 456 by the number of parts, which was 19. So 456 divided by 19 is 24. So what that's saying is it's 24 kilos per part of the ratio. Now, what did they ask for? They asked for glass. You see how glass is the 7 on the right hand side? It's the 7. I don't need to actually work out the paper. Obviously you can, but you don't need to. So ignore the paper, just look at the glass. The glass is 7 parts. So if it's 24 kilos per part, and I've got 7 parts, I'm going to multiply it, aren't I? 168 kilos. So that's my answer, 168. Okay, so just a bit of a percentage and then a bit of sharing out ratio. That's literally all that is for a nice 3 marks. Okay, question 26. A number D is rounded to 1 decimal place. The result is 12.7. Complete the error interval for D. So you need 2 values, basically. You get obviously 1 mark for each value. So if it's rounded to 1 decimal place, just think, well, what's the smallest value that it originally could have been to make them round it up to 12.7? And same idea, what's the biggest value it could have been that would then make you round it down to 12.7? So this is kind of the same as, well, actually I don't think that's relevant, let's not say that. What's the smallest value it could have been to 1 decimal place would be, if you think about it, if, let's say, for example, you had 12.62, if they said round that to 1 decimal place, that would round down to 12.6, wouldn't it? So that's too small. So you see what I'm saying? I'm just going to keep, and then if I got 12.65, if you saw that, and they said round it to 1 decimal place, you should round it up, wouldn't you? You'd round that up, and obviously then 6.6, 6.7, anything else. So the smallest possible value it could be to round it up would be 12.65. Effectively, you're subtracting, 1 decimal place is this, isn't it? 0.1. You're subtracting half of that. You're adding and subtracting half of that. So you see how we've got 12.65. So it could be 12.65 or anything bigger. Now the upper one, the biggest value, is then if you add the 0.05. Oh, apparently I cannot write numbers. Is 12.75. Now, I know that you're going to say, oh, but that would round to 12.8. Yes, technically. However, just look at the inequality symbols, right? Because they've said that it could be equal to 12.65 or more, but the upper one is not equal to, is it? It's just anything less than this. So it doesn't technically include 12.75, but what it's saying is anything slightly less, because the problem is technically it'd be 12.749999, like to infinity. And I can't write that many 9s down. It would take me too long. So that's why you just write down, I know it would round up, but that's why they've put just less than 12.75, not equal to 12.75, just anything less than that. So it's just whatever they've rounded it to, you take half of that. So half of 1 decimal place above, half of 1 decimal place below. So the original number was somewhere between these 2 values. Now, question 27. Tamsin buys a house with a value of £150,000. The value of Tamsin House increases by 4% each year. Rachel buys a house with a value of £160,000. The value of Rachel's house increases by 1.5% each year. At the end of 2 years, whose house has the greater value? Now this is actually, it relates to compound interest. I know the context is not interest, the context is houses and value, but the compounding is the same. Now you have the formula for compound interest on your formula sheet. It's something, I don't know if they call it principal amount, they say something about like the initial amount, times by 1 plus the rate, the percentage over 100, to the power of, I think, n, which is the number of years. We can apply this. There's just 2 scenarios here, isn't it? So deal with them separately. So Tamsin, her initial amount or her principal amount, the starting value basically, what is she starting with, is 150,000, isn't it? 150,000. And then you times that by 1 plus, what's her percentage? 4 over 100. And then it's 2 years, isn't it? So to the power of 2. So I'm just building that formula from my formula sheet. 150,000 times 1 plus, and then you can obviously put it as a decimal if you want, but this is just from the formula sheet. And then squared, just that bracket squared, not the whole thing. That gives me 162,240. Yeah. What was it? 240, yeah, I was thinking 420. So that is one of them. Now I can work out Rachel, same exact formula, but obviously do the different numbers. So her principal amount, or her starting amount, is 160,000. And then I've got 1 plus, now this one is 1.5%, so over 100. Now it's also still for 2 years though, isn't it? That's the same. So go back, 160,000, make sure you've got enough zeros, times 1 plus 1.5 over 100. Over 100 squared, and that gives me 164,836. 164,836. So those are the values of their houses at the end of the 2 years. It says whose house has the greater value. We just look at the one that's bigger, right? So you have to make a decision. So it's obviously going to be Rachel, isn't it? Rachel. And that's 4 marks. There's obviously quite a few marks, that one. Now, this is our last question. So 28, here are 5 graphs. The table shows the equations of these graphs. Match the letter of each graph with its equation. So the first one, we just have to recognize what these are and obviously what the graphs are. The first one is a quadratic graph. So a quadratic graph is a U shape, isn't it? So have a look, which one is a U shape? B. Okay, that's fine. The second one is a straight line graph. Now, we have actually got 2 straight lines, haven't we? So let's leave that there for a second. The third one, x cubed, is a cubic graph, which kind of looks a bit like something like that. Do you see how that would be E? So we've got rid of E, we've got rid of B, process of elimination. This one here is what we call a reciprocal graph, and that one looks a bit like this, so that is C. And then the last one is also a straight line. So now we just need to determine which straight line is which. Now, sometimes I would say look at the, well, let me write this down. This is the equation of a straight line, isn't it? Y equals mx plus c. M, or the number that's in front of the x, is the gradient, so how steep is the line, and the c is the y-intercept, where does it cross the y-axis. Now, unfortunately, in this case, obviously, this one's written the wrong way around, isn't it? This one is, if I write it the correct way around, it would be minus 2x plus 5. That's a 5, that's a 3. So when I look at the y-intercept, because it's not drawn that accurately, I can't really use that to determine it. It's not very obvious, is it? So what I would focus on in this case is I'd probably focus on the gradient. Do you see how this one, I mean, there's no number there, but that means 1, doesn't it? But also, there's no negative or positive. It's a positive, isn't it? So that's a positive gradient. This one here is minus 2. So that's a negative. See how that would be going down? This one goes up, that one goes down. That's how I'd figure it out. So the first one is going up, a positive gradient, so that's D. The second one is going down, so that's a negative gradient, so that's A. So B, D, E, C, A should be in that order. So you just have to learn to memorize what these graphs look like, recognize them, recognize their equations, then you just match them up basically. So that was it for the final question. And there's all of your questions, 80 marks. So as I said, you had about 8 or 9 questions there that were technically overlapping with the higher tier paper as well. If you have any questions about this paper, please feel free to leave them down below in the comments, or obviously during the lives, you can also leave them in the live chat. But otherwise, if you have questions after this, put them into the comment section. We are going to be doing foundation papers for Edexcel, 5 o'clock, Monday, Wednesday, Thursday, probably most of the days this week, actually. I'm thinking about it because it is obviously half term. So yeah, thanks for joining me today, guys, and hopefully I will see you, the next one will be on Wednesday.